Okay, 5-2 sequences. My first question to you is this, not that, but this. What is a sequence? If I had to ask you what a sequence is, what would you tell me? Zane? Okay, so that kind of goes in order. Okay, yep. A pattern of some sort. One thing after another. Good, good. I'm liking what you're telling me. Somebody would tell me it's a game. You heard of the game sequence? Okay. But yeah, everything you guys pretty much said is right. It's something that goes in a certain order and it kind of repeats after each other. So a sequence is a list of numbers in a specific order. A sequence is a list of numbers in a specific order. And then the terms, those are the numbers in the sequence. The numbers in the sequence. Okay, so here I have a sequence on the bottom. It's a pretty simple sequence, 1, 2, 3, 4, 5, 6, 7, 8. If I had to ask you, what would be considered a term in that sequence? Jasmine. 3 is a term. Yep, what's another term, Connor? 6. If I asked you how many terms are in that sequence, what would you tell me? 8. Okay, so let's do another one quick. 5, 2, 4, 6, 8, 10. How many terms are in this sequence? 5. What would be considered a term in there? 4, 6, 8, 2. Okay, does that make sense? What's the first term in this sequence? 2. What's in the second place of the sequence? 4. Yeah, the second spot would be a 4. What about the last spot in the sequence? Would be a 10. Okay. And what term is this? Term number 5, right? 10 would be term number 5. Does that make sense? Term 1, term 2, term 3, term 4, term 5. Everybody understands what I'm talking about there? Okay. Good job. So today, I'm going to talk about 2 different kinds of sequences. I'm going to talk about a arithmetic sequence and a geometric sequence. Your homework today focuses on arithmetic sequences. But I'm going to talk about geometric because I think it's something you could see on a STAR test. Just to give you kind of a little idea what it is. I'm not going to spend a whole lot of time on it, but I still want you to know what it is. An arithmetic sequence. This is a sequence where you can get to the next term by just adding or subtracting. Okay? Arithmetic. Adding or subtracting. Cadence. Yes, and I'll talk about that in a second. Yep. Okay, so I have a sequence here, 2, 5, 8, 11, 14. And so I know this is an arithmetic sequence. How can I tell this is an arithmetic sequence? How do I know, Zane? Yeah. See how I'm going up by 3 every time? To have a sequence as arithmetic, I'm just going to say what I told Cadence before. It has to go up by the same thing every single time. You can't go up by 2, and up by 6, and up by 1, and up by 9. It doesn't work that way. It has to be consistent. So in your homework today, it's going to ask you 2 things. It's going to say, what is happening here? What's it going up by? Okay, so what's it going up by? 3. So you would say, okay, you're adding 3 to each term. That's what you would say. And then it's going to ask you, what are the next 3 terms in this sequence? What's one of my next terms? Yep, because I know I'm going to add 3 to 14, right? And that's going to give me 17, 20, 23. So each question is going to ask you 2 things. It's going to say, what's it going up by, or what's happening. Then it's going to say, find the next 3 terms. Okay? Not too difficult, right? If I didn't know what it's going up by or down by, what can I do to figure that out? If I don't know, what can I do? I can subtract, right? I can just take 2. I got to take them right beside each other, though. Take 2 terms beside each other and say, okay, what's 5 minus 2? Well, I know it's 3. Well, 8 minus 3, 5 is 11 minus 3, 8, and so on and so forth. Yep. Nope, 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 it's going to be consistent. Nope, always plussing, always minusing the same thing, never all over the place. Because then, if it's like that, let's say it's like one like this, plus 3 minus 2, plus 4 minus 1, plus 5 minus 7. Can we tell what the next 3 terms are going to be? No. So that's why it has to be consistent throughout. Like yours, minus 2 plus 2, you could probably tell, but it's always going to be the same. So you can easily tell what the next 2 are. Okay. Let's look at this one. Tell me what's happening, and then tell me the next 3 terms. So we go 4, 12, 20, 28, 36. Okay, so we're adding 8 every time. I don't even care if you write it like that, adding 8, that's fine. What's my next term then? 42. Next one. 44. Just testing you guys. Now what? 52. 60. Okay. Good? Everybody understand how this is going today? If I was subtracting, would it be easy to tell too? So let's say I'm going like this. What's going on there? Subtracting by 2. And my next one would be 12, 10, 8, right? So a geometric sequence, let's quick talk about this. I know you're not going to see a whole bunch of this in your homework today, but I still want to talk about it because I'm afraid you're going to see it somewhere else. So when you find the next term by multiplying or dividing. All right, so I have 2, 4, 8, 16, 32. It's going to be something we're multiplying by. What are we going to multiply by every time? 2, so 2 times 2 is 4. Oop, times 2, times 2, times 2, times 2. So I'm multiplying by 2. My next term, 64, 128, right? The next one would be 256. Okay, everybody understand how we find these? Connor? What would you do? First, I would eliminate arithmetic. Because I know it can't be arithmetic. Well, this plus 2 would be 4, but plus another 2 would be 6. So I know it's not arithmetic. So then I have to go, okay, geometric. What's happening? I would take, well, what's 4 divided by 2? 2. What's 8 divided by 2? What's 16 divided by 2? That's what I would start doing to figuring it out. I would eliminate arithmetic first. Then I would start guessing with geometric. And you know, if you look at them, a lot of times you can tell what they're going to be. Because if you have an arithmetic or a geometric, it's going to go up faster. Think about it. If you're multiplying by something, your numbers are going to get bigger sooner. You know, if you're just adding, it's only going to go up a little bit each time. So, all right, tell me about this one. Multiplying by 3. Now what? 27 times 3 would be 81. Times 3 would be 243. Is that right? Times another 3 would be 729. Is that right? See how it goes fast? Yeah, you kind of know it's going to be a geometric because it goes up from, geez, there's 7 terms in there, and the first one is a 1, and the last one's a 729. So you know it's going to go up fast, so geometric. You know, even if you go down fast, too, because you could go down fast and have it be division. You know, think about it. So if I do 20 divided by 2 would be 10, divided by 2 would be 5, divided by 2 would be 2.5. Well, even look at that. You know that. Look how fast it goes down. Probably division then. Okay. Let's look at these two. Let's look at these two sequences. Figure out, these two are not arithmetic or geometric. There can be other sequences out there. So here's two that are not geometric or arithmetic. See if you can figure out how they go. Everybody got it? Let's talk about the first one. Just look at the first one. It goes 1, 1, 2, 3, 5, 8. It's not arithmetic. It's not geometric. There's another thing that's happening in there. Are you ready to give it a whirl? Merrick, you're looking at me funny. Am I stumping you? Mr. Augustine, what do you think for that first one? Nope. Good try. Good try. Dane? Yeah, look at 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. The next one would be what? 13. The next one would be 21. See how it goes? See, I'm just showing you there's other sequences out there that aren't always going to be a geometric and always going to be arithmetic. Okay? Why is this one not arithmetic? Because you're always adding the 1 in front. It's not being consistent, is it? No. What about this one? Henry thinks he's got this one. Hold on. Let's let everybody think about it. I'll let you answer. Let's let everybody think about it. Nope. Okay, see how fast it goes up? There's got to be something going on with that. What do you think, Henry? Okay, so it goes up times 2, times 3, times 4. What would the next one be? Times 5. Even though you're multiplying doesn't mean it's geometric. It has to be the same. You want me to give you another one? Okay. This will be harder. Oh, obviously not. Just wait. Let's let everybody think about it. Huh? It's kind of fun, isn't it, to figure it out? You think? It's okay if you don't get them right away. It's just for fun. Kaylee, you think you got it? What do you think? Good try. But that's a good theory, though. So it goes up by 3, 5, 7, right? That's not it. That's not what I was thinking about. What do you think? It's a perfect square. 1 squared, 2 squared, 3 squared, 4 squared. But I never thought of yours. Yours would work too, because always adding by an odd. That's another one. Yeah. I love this. This is fun. Sorry. Okay, a few more things I need to show you. So we've been talking about algebraic expressions. Now I'm going to show you how to write a rule for a sequence, okay, and how this works. So I made a chart, but I'm not going to take this out, okay, because I don't really like that very much. So here's my chart, and here's my sequence. So I got 2, 4, 6, and 8. Now we're going to write a rule for the sequence to figure out what my next term, or to figure out what my next terms are, okay? So when I have my sequence, I have 2, 4, 6, and 8. Now my first position would be like term 1, term 2, term 3, term 4. Do you see that? Okay, so my position 1, do you see my position 1? Does that make sense? My term 1. What's the value of term 1? 2. What's the value of term 2? Okay. What's the value of term 3? Okay. And the value of term 4 is 8. So now my job to see is this. What's happening between position 1 and value 2? What's going on from, how do I get from 1 to 2, 2 to 4, 3 to 6, 4 to 8? What am I doing? I'm multiplying by 2. So I'm taking my term, and we're going to call this n, because we don't know what position we could be talking about position like 6. Okay? So you're going to take your position, and we're just going to give it a letter, n, and what are you going to multiply it by? 2. You just wrote a rule for this sequence. So if I asked you what in position, let's say, term 10 is, what would be in term 10? 20. Does that make sense to you guys? So like if I would keep going here, I would have 10, 12, 14, 16, 18, 20. And what position is term 20 in? 10. So I can find what any number is in my sequence if I just write a rule for it. Does that, you guys kind of like following what I'm saying a little bit? Okay, so let's try another. Okay, so here's 3, 6, 9, 12. Let's write a rule for my sequence. So my term 1, term 2, term 3, term 4. I could have 5 and 6 and 7, but I don't have them yet, okay? So in position 1, let's just do this. Term, value, maybe that's easier to understand. Term 1, what's my value? 3. Term 2, what's my value? 3 is 9, 4 is 12. So what am I doing? What's my rule? I'm taking my term timesing by 3, right? So I'm taking this number times 3. So now, if I don't know what term I'm talking about, let's say I'm talking about term 25. What can I put here? I can put that a D or T or whatever. Okay, or maybe T would be better for term. So if I wanted to find term 5, I would take 5 times 3. That's what I'm going to be, 15. If I want to find term 7, 7 times 3 is 21. So 21 would go here. 15. And what's the other one? 18? Let's say we want to find term 100. Let's say it goes on and on forever. What's term 100 going to be? 300. What's term 300 going to be? 900. Do you see how I can use my rule to figure out whatever term I want? You guys have questions? Pretty simple, right? Okay, you might have to use that today in one of your things of homework. Okay? And then, like, I have a story problem quick for you. Okay, just bear with me, and then I'm almost done. Greeting cards are sold in boxes of 5. 1 week, 5 boxes are sold. Each week after that, 5 more boxes are sold. The pattern continues. Write an algebraic expression for the sequence. How many boxes are sold in the nth week? Well, first of all, term, value. So my first week, how many boxes are sold? 5. My second week, 10. And my third week, 15. And then so on and so forth. You can probably write a rule. My rule would be what? Times 5. So I'm going to take my term and I'm times by 5. And then it asks me, if I'm going to have 100 weeks, how many boxes are going to be sold in that 100 weeks? 500. Because I would take my 100, because that's going to be my next week or whatever, times 5, 500 boxes. Any questions on how to write a rule? Okay. Yeah, it is. I agree. Why don't you get your books out and let's talk about your homework today.